So getting started with Tezos, this is what we're going to cover. Uh, Blockchain overview, then a quick introduction to Tezos, then some things about how Tezos is architected, and why should you use Tezos, why should you build on Tezos, and how we start developing on it. So a brief introduction about myself before I get into this. I am a blockchain developer, and I work with Tezos India, and try to help them analyze blockchain projects, analyze use cases. Other than this, I have a couple of other sort of small projects and blockchain startups that I head and I lead and I'm part of. So yeah, I have been working on blockchains for more than 4 years now, and so I think I have a good bit of experience to help you guys with this. So yeah, what is a blockchain? It's a buzzword that you would hear quite a bit, but beyond that, trying to demystify it, it's an immutable, tamper evident shared digital ledger that is supposed to record transactions in a decentralized peer-to-peer network. So these are this might seem like heavy words, but it's actually not that hard once you understand some basic nitty-gritties of how it works and what it is. So yeah, it's think of it as a ledger which is contained of a chain of blocks that are tied cryptographically using what are known as cryptographic hashes. And what makes it immutable and tamper evident, tamper resistant is the fact that it is shared across this entire peer-to-peer network. So you can't just go and overwrite something somewhere. So yeah, it's distributed to all members across the network, and it stores records as we mentioned. So that's a blockchain. This is what it looks like. There are two main aspects of how three main aspects I would say of how a blockchain is how a blockchain works under the hood. So there is one. The first aspect is the actual data structure aspect of it. So now I'm going to assume that all of you are familiar with basic computer science concepts. So I'm not going to go into things like linked lists and all of that, because I'm assuming you guys know all of that. But yeah, so think of it as a chain of blocks that are linked, similar to a linked list, but not same, of course. Linked using what are known as cryptographic hashes. Cryptographic hashes are one-way cryptographic functions which take any input and produce an output of fixed length. So that's what a hash function is. They have some properties which, for the sake of brevity, I'm not going to go into. And each block that you see here contains a set of transactions, right? So it has some metadata, which is like date, time, when the block was minted, when who mined the block, and how much reward they got, and all sorts of metadata that is associated with the block. And it contains what are known as transactions, right? So that's not put in this diagram, but these transactions are like I gave one of you 10 bitcoins, or someone gave me 5 Tezos, all of this. So these are the transactions that constitute a block. Now, so this is the data structure, but how the peer-to-peer network, so this is the second aspect of the chain, how the peer-to-peer network, which is basically like this distributed network, geographically separated by, and each of them run what is known as a client or a full node or nodes of the blockchain, right? And they maintain the actual ledger. So each node or each client or each participant of the peer-to-peer network maintains the entire ledger. And how they reach, how they know which ledger or which block to accept, and how what is the current state of the blockchain, that is achieved by what is known as consensus, right? So there are different types of consensus. Consensus is basically like how you sort of come to a consensus as to what block and what transactions are valid, right? And consensus is a very hard problem to sort of solve, which is one of the key things that blockchain solves. I mean, just try to think of it. If three of you want to go out for dinner, it's bloody hard to figure out which place to go to, which movie to go to. So consensus, arriving at consensus amongst parties that know each other is hard. Imagine what it would be for parties that don't trust each other, that don't know each other. How do you arrive at consensus on what is right and what is not, which transaction is valid, which transaction is not? So That's what a blockchain is, and that's how it's built. Um, why blockchain? Because it provides us a lot of things. It provides us transparency. It provides a decentralized architecture where there is no central authority and you can eliminate the middleman. It provides open participation. So this is particularly true for public blockchains, not so much for permission blockchains like Corda or Hyperledger. Um, it is immutable because whatever is written on the chain cannot be tampered with, cannot be erased, and it is trustless. Trustless is a word that you might not have heard very frequently, but what it means is need to trust. You don't need to trust a bank to sort of tell you that that, let's say, Mudit owns $100, or you don't need the bank to tell you who owns how much, right? So yeah, so you can trust that whatever is on chain is correct, whatever the smart contract. Okay, so we're going to come to smart contract, but yeah, so that is the central point of single source of truth, right? So you can trust on that and not on potentially malicious actors. Right. So what are smart contracts? Smart contracts are what makes blockchain smart, right? So smart contracts are basically programmable, self-executing piece of computer code. So there's self-executing programmable software that live on the blockchain, which means that they are stored within the state of the blockchain, and the purpose is to dictate terms of a contract or an agreement between parties. So think of regular contracts, any contract like house agreement or uh, bonds or employment contracts. So when all of you are gonna sort of graduate, you're gonna go to a city which probably is gonna be not gonna be Rourkela, I'm assuming, but yeah. So you're gonna have to get a place. You're gonna have to get a job, and all of that would require contracts. So basically, those contracts have to be attested or governed uh, by government organizations like notaries, and which provide the trust. So when you have a rent agreement, there is a notary that sanctions that this is valid. And so yeah, smart contracts remove all of that. They put everything on code, so you can trust the code. If the code is correct, things will happen, right? A very simple example in the case of a rent agreement is that if uh, if a tenant and a landlord are going to have a contract, what they're going to do is they're going to have a contract which says that by the 5th of the month, if the landlord does not give the keys to the contract will act as an escrow. I hope you guys know what an escrow is, but it's basically like a middleman that holds funds from both the parties. That's what an escrow is. Safely holds the funds. So the escrow can hold the money from the tenant and the keys from the landlord until both of them don't send it. So your money will not go to the landlord unless he sends the key. So that's what a smart contract does. Yeah, so this is what a smart contract is. Different parties can talk to it, and it creates a transaction that are included in a block, and that is the blockchain. So uh, that's the diagrammatic representation. Now we come to what is Tezos, right? So Tezos is one of the most popular blockchains that exists currently. A couple of other blockchains are like Ethereum and Cosmos, Polkadot, but Tezos is one of the very famous ones. It's an open source blockchain, and it supports smart contracts that can be used to build dApps. dApps are basically decentralized applications that use one or more smart contracts running on a blockchain, right? So that's a decentralized application. There is no centralized control. That's why they're called decentralized apps. Yeah. So some cool features of Tezos is that it's a self-amending blockchain, and there is on-chain governance. So you don't need to, the blockchain evolves as the community wants. So it's a self-amending blockchain with on-chain governance. So that's one of the most important aspects. And the other important aspect for developers is that it supports what are known as formal verification of contracts, which means that we'll get to what it means, but you should understand that it helps you. We'll come to it actually, I guess. Yeah. So consensus, as we all understood, it's a hard problem to solve, right? There are multiple blockchains solving it in different ways. So Bitcoin, Ethereum do it in proof of proof of work, right, which is mining. And I'm not going to get into that, but how Tezos does it is what is known as liquid proof of stake. where all the validators stake in some funds, right? Some Tezos that they own. They stake that into the system to validate blocks, right, and to create blocks. So they're known as bakers. They bake blocks. That's how Tezos calls it. And every time a new block is baked, a random validator is supposed to, is baked by a random validator, and other validators need to endorse that the block is correct. So that ways it makes it scalable. Ethereum and Bitcoin, they rely on what is known as proof of work, which is very computation intensive. So Tezos takes a different approach, which is called proof of stake, liquid proof of stake, which is a more interesting approach in that regard. It's more efficient. So yeah, this is Tezos speaking in a diagrammatic representation. So there are different delegates who can delegate their token to a baker, amongst which a random baker is chosen, and also 32 random endorsing validators are chosen. The baker proposes a block, and the validators endorse a block. As soon as all of this is finished, the block is ready to be added to the chain. This is a very ugly architectural diagram of how Tezos is designed. So basically, there is a full node, and it talks to different aspects. It has the networking layer at the lowermost layer, which is the P2P networking layer, which talks to different clients using RPC. And RPC is basically an interface through which different clients can talk to it. So they use what is known as HTTP and JSON formats. But don't feel sort of troubled or scared if you don't understand a lot of it. Probably even I don't, so don't worry about this. We'll get to actual stuff which will make things clearer. So Tezos smart contracts. With smart contracts, there are a couple of design challenges that need to be overcome, and I'm assuming some of your computer science students you've sort of learned about compilers and compiler designs. So that's integral in designing smart contract and smart contracting languages. So yeah, smart contracts in Tezos are compiled and executed in Mickelson, which is a low-level domain-specific, meaning that it is just meant for Tezos smart contracts. It can't be used like Node.js or Java or JavaScript or any of those languages which can be used like Python, which can be used at multiple places. So it's domain-specific. It is used just for writing Tezos smart contracts. It's a very low-level language, and it's a stack-based programming language. I hope you all know what stacks and queues are, and especially what stack-based programming languages are. So stack is, I think, first in, first out. Yeah, that's what a stack is. So yeah, they support formal verification of contracts. What that means, we left that from some slides ago, is that so one thing that you should understand about smart contracts is that since the blockchain is immutable, any smart contract that you deploy on chain is also immutable. And what that means is that if you write a buggy smart contract, or if you write a contract that has some vulnerability, right, there is no way to change that. It's not like software that you can upgrade. So smart contracts, once written and deployed, are there for life. If there is a vulnerability, if there is a bug, that stays, and it is open for everyone to exploit, right? So this brings a lot of security concerns while writing smart contracts. They need to be audited, they need to be tested thoroughly, they need to be battle proven, right? So one step that Tezos takes in that direction is basically supporting formal verification of contracts. And what that means is that whenever you write contracts, you can support it with some test suits, some test cases to run the smart contract against and formally verify its output. We will see an example of this. And yeah, the third and the most important point is that since Mickelson is a very low level and stack-based programming languages, it is not very easy for for a lot of people, a lot of developers to use. Therefore, some languages like SmartPy and Lego, which are high-level languages, which exist to make life easier for developers like ourselves. So you can write code in SmartPy, which is like a Python library. You're going to touch upon it, and Lego, which compiles to Mickelson. So that's an advantage. Before I head to SmartPy, I'm just gonna see if there are any questions. Okay, no questions yet. All right. Do feel free to ask me questions if you have any doubt. Yeah, so SmartPy is this Python library which is used for constructing Tezos smart contracts. And yeah, being a library, the advantage is that it can extract the full power of Python, and it can draw Python libraries, other Python libraries to build smart contracts and use existing data structures, call other libraries. So yeah, it's very powerful way of compiling code to Mickelson. And SmartPy code is written on SmartPy ID. We look at that, and that has a lot of tools like a compiler that generates Mickelson code from your Python code, and a simulation engine where you can simulate your contracts and sort of formally verify your contracts, test your contracts in a simulation environment. So it supports a simulation engine, and it has a contract explorer, a wallet, a lot of other things. So we look at SmartPy in a bit. And yeah, these are the tools that you should use for development. So there is Tester, CLI, and GUI, which is built by us in India, and it's basically a way to spin up your own blockchain nodes and test and deploy your smart contracts. So that's Tester. SmartPy ID is something that we're going to look at. Taquito and Conceal.js are basically like JavaScript libraries, JavaScript and TypeScript libraries for your backend and your front end to talk to blockchain. So it enables your backend front end to talk to the blockchain, right, using JavaScript. So these are very popular libraries. And the final tool that I want you to know of is Beacon SDK, which is basically an SDK that allows you to integrate wallets into your front end. So for using these applications, you would need a crypto wallet where you would have a Tezos account and do all sorts of stuff. So let's get hands-on. We're gonna write, compile, and deploy, and interact with a lot of with one smart contract and see the transactions and blocks on chain. That's the plan. Um, yeah, before I head to the IDE, I'm gonna just take a pause and just open up for questions if anyone has anything, or else I'm gonna.
Anyone willing, they can obviously join the stage. You can raise your hands. We can get you on stage if you want to ask directly. If you have any questions, feel free to ask under the questions tab or in chat.
I see a lot of people asking about. Oh, these are old messages, slides. If you want slides, we can share slides. But yeah. Uh, okay, there's a question from Vidit. The question is basically Tezos is for payment transactions. Not really, Vidit. That is one of the use cases. It's just one of the very tiny use cases, I would say. Um, Tezos can be used for a lot of things. It can be used, for instance, I'm currently building a marketplace on Tezos. So it can be used for a lot of use cases. It can be used for, in fact, as a part of the hackathon, I believe you guys should look at some use cases like, uh, for building wallet apps, for building, games on Tezos. So I think there is a game called CrickTez or CTez that's being built up. So you can, so games can be built or tools can be built. So a lot of things can be built on the on Tezos, and there are a couple of hackathon ideas that I would want to sort of quickly go through at the end of this. But primarily, like games and sort of financial applications is what Tezos is insanely good for. So you can build a lot of financial applications, lending, borrowing, marketplaces. What else? Interest generating bonds. A lot of things. So yeah. Is I hope that answer your questions with it. And let's see. Astha wants to know if there is a library in any language other than Python. Yes, Asa, there are a couple of other libraries. There is there is something similar to Haskell. There is Lego, which is similar to Camel Case. There are a few other libraries that you can use to build your smart contracts, but I'm assuming none of that would be very commonly known by students. So I think Python is your easiest bet. It's the simplest, and it's the one that I would recommend. So uh, Vidit wants to know, can Tezos be integrated with Mern Stack? Yes, of course it can be. Yeah. So with your React and so Mongo, of course you can, but with React Express and Node. So with Node you can use I think we mentioned Taquito and Conceal, which can also be used at the React end. So it can be. It has to be integrated with Mongo Stack. Yeah. Twitch. All right. Is the ledger in blockchain decentralized? In that case, does every node have a ledger? That's a very good question, Divich. So the question is, yes, the ledger is decentralized. So yes, it is decentralized. In that case, does every node have a ledger? Yes, that's correct. Every node has to have a ledger. How does every node get updated so fast? That's a good question. So this is a networking level question. Um, a lot of blockchains use what are known as gossip protocols. So these nodes uh, gossip amongst themselves, and as soon as they receive a new block, they propagate it to the nodes that they're connected to. So in a peer-to-peer network, not every node is connected to all the nodes. A node is connected to a few nodes that it knows, that it trusts, right? And those nodes are further connected to a few nodes that they know and trust, right? So that's how the entire web is built of the entire peer-to-peer network is built. And in this, the messages of block produced and block accepted and block added to my chain, these propagate using what are known as gossip protocols. So yeah, that's why they're not always very fast. It takes a bit of time. So if I produce a block in India, it might take a while for it to reach the states, right? And you will see it first appear in block producers here in their ledgers and then there. So it's not completely seamless. It does take a bit of time, but yes, it is fast because of gossip protocol. Okay, the next question is functioning on blockchain similar to the way Torrent works? Yes, it is pretty much similar to that. In fact, there is a blockchain called BitTorrent which works on very similar principles as Torrent. But yes, there are a couple of differences. It is not just meant for file sharing, and it's meant for sort of uh, a lot of other use cases, right? But yes, that is one of the use cases. Such. All right. Uh, so in case of blockchain Bitcoin, where does the coin live? Which you're asking some good questions. Uh, the answer is actually gonna slightly scare you. Is that in Bitcoin there is no coin actually. The coin does not live anywhere. It neither lives on the wallet nor on the node server. It uh, in Bitcoin, what actually exists and what people don't know about. What exists is basically a private key that controls the that gives me control of that Bitcoin. But that Bitcoin essentially is what is known as an unspent transaction output, UTXO, right? And what this is that it basically okay. So think of a transaction, right? In a transaction, there is some input, there is some output. So which if I'm sending you a Bitcoin, I need to own that Bitcoin, right? So I sent an input in the input, I sent an unspent transaction output. I send in the input an output that I have not spent. So unspent transaction output that I received from, let's say, Asta. So Asta sent me a Bitcoin in the past. I have that one Bitcoin, right? Which is an unspent transaction output. So I received it as an output in a previous transaction and I haven't spent it, right? I use that UTXO, or the unspent transaction output, as an input to this transaction where I'm sending you that one Bitcoin, right? And as soon as I process a transaction, my my output that I had is consumed as the input. It no longer is existing, and a new output is created as a result of this transaction, which becomes the new UTXO that belongs to you, that is controlled by your private key. So that's actually how, and a couple of other cool things is that these UTXOs can be fragmented, right? So if I have received one Bitcoin from Astha, I can split it into two parts. If I have to give you half a Bitcoin, and I have to keep half with myself, I can split that UTXO into two different UTXOs. One I can give you, the other I can take back to myself. So that is how things work in the Bitcoin world. So yeah, I mean, coming back to point, the coin actually doesn't exist. It is just the private key, which is existing within the wallet, that has control of these UTXOs. So that's how it works. Hope that makes some sense. All right. If there aren't any other questions, we can get back to our hands-on. I'm going to share my screen again. Let me know. Yes. Okay, Rutaj has a question before we. The transaction output is what we could term as the coin, right? Yes, yes. But I want you to understand that a lot of people mistake that the wallet stores the coin, which is not true. The wallet does not have the coin, and the coin actually is just this unspent transaction output that is there. It's not a physical coin. But there are some blockchains which take a different approach. For instance, Ethereum and Tezos also, for that matter, have each account has a balance, which is like an entry, has an account which has a balance, which is basically like an entry in their account state, right? So there you maintain all the balances. So that is how the Tezos currency works. So and Ethereum also. So that's a quick difference. Cool. I'm going to get into the ID and show you the contract, and then we're going to jump back to questions if there are more. Uh, Awesome. So this is SmartPy. This is what the ID looks like. The way to reach this is smartpy.io, and I'm just gonna make sure you know how to reach here. It's a product that's in development, so it always keeps changing every time I arrive here. So there are some things that I might not be familiar with, but yeah. So this is the way to reach the online editor. There is a CLI, and there are some references also, which I'm not sure where they are, but I'll still show you. So if you click on online editor, you reach this place, which is this, after a lot of load time. So it does a lot of loading and then finally takes you here because it imports all the libraries. So yeah, this is a smart contract. As soon as you go in, you will see a newcomer mode enabled, and I would suggest all of you keep it enabled for you to sort of understand what is happening. So we're going to sort of quickly walk through a small contract that I've built. It's a very simple store value contract. Um, it has three functions. So basically, every contract is a class. And yeah, so this is something that I want you to look at. So this is the import of SmartPy library. So as I mentioned, SmartPy is a library, and that is what needs to be imported in your contract to sort of, uh, one second, let me clear all of this. Uh, okay, forget it. So yeah, so this is how you import the SmartPy as SP, and then you start using the entire library to build your contract. So every contract is basically a class that that sort of implements and extends the sp.contract, and it has an init function which takes a couple of things which you can customize, of course. So let's say I'm creating this contract that just does two things. It stores an initial value, and it can double it and it can replace it, right? and of course it can also divide it. So yeah, so these are the functions. These are what are known as the entry points. You see we've annotated it with sp.entry point. What entry point means is that these functions of the smart contract are exposed to the outer world. So I can have another function, for instance, say let's say I have a function called def hello, which just does some things. But if I do not put in an entry point, that means this function is an internal function. It is not exposed to the outer world. It's not an entry point. So that is the purpose of having an entry point, right? So yeah, so these are this is the state variable, and whatever owner I pass is passed on as owner, right? Um, just give me a second. My battery is about to die. Yeah. So there is a function called replace. What it does is it takes a params.val, it takes a value and it replaces the stored value with this value. It's a very simple replace function. There is a double function which, as you would imagine, doubles the number, and there is a divide which takes a parameter and divides it by 5, right? So let's remove this, or let's comment this actually out. So I wrote a small condition that the divisor that you send here should always be greater than 5. So this is what you say. You say sp.verify that this condition is true. Whenever the params is sent, this condition is true. If this condition is not true, then you throw this error. So this is the format of writing sp.verify, right? And as soon as you verify that the divisor is greater than 5, you divide the value by 5. And there's a make zero function. We look at this. This part of the contract is where you define the test cases. And this is exactly the part that lets you formally verify the contract. So before anything else, I'm going to sort of quickly run the contract for you and show you how it works. So this is how the contract runs. And okay, finally. So if you see, this is the contract that came here. This is the owner of the contract. That is me. My address is being used here. And there is a stored value, which is 100, because you see, we initialized this contract. C1 is, so this is the test here. We've said sp.add_test, and the name of the test is store value. And then we've defined the test here. Forget about this Alice for the instance. What this is I'm trying to initialize a stored value class, which is the actual contract, and I'm passing it two things, as it needs one value and an owner. Owner is an address, so therefore I've instantiated a test account called Alice, and then I'm passing the address of Alice. So yeah, then I'm creating a new scenario, which is sp.test scenario. I'm instantiating a new scenario, then I'm adding some headers, and then I'm adding the contract. Don't worry about all of this if you don't understand all of this. This is fairly simple. You'll understand this. A good way to learn all of this is by going through, I think it's here. Yeah, a good way to look at it is the reference doc. It has brilliant resources. It has the entire, syntax and everything. So this is your go-to place for building smart contracts. But coming back to where we were, so these are the entry points that you see here. So you see there are entry points, and as I said, if I create an entry point without um, an entry point, if I create a function without an entry point, it's just not going to show up there. So yeah, that's something that you should be aware of. So these are entry points, and I'm not sure why it's taking so much time, but see, so this I should have called it replace one, but yeah, the point is this will not show up there, right? So you can test it out at your leisure. So you see these are all functions that have been come here. Now these are the test cases. So let's look at some test cases, right? So the first test case that we called was line 35. You can see this. We did a C1, we called the function replace, and we put in the value 15, right? So this was the function. This is what there is. This is a summary. And this is what happened. Before this, I actually want to quickly show you that, or actually I'll show it to you after this. So what we passed was value 15, and you see after this was executed, what happened was the storage of the contract changed. Initially, the storage was 100 as soon as we deployed the contract. The storage then became 15 because what we did was we replaced the value by 15, right? After that, we did some computation. So some computation is here, and we just multiplied the value by 2, and we showed it. So the value is 15 into 2, 30. Then we replaced the value by 25. So you can see the replace call. So there are the replace call was called, the value was 25, and boom, it's 25 now. Then we doubled the value, right? So you should see a double function here. Exactly. So there is a double function here. And it doubled the value. So now it's 50, right? And then I did a divide here, right? In line 31. So there should be a divide, and there is a divide. I divided it by 2. As you would remember, we had a verify clause which said that the divisor has to be greater than 5. It cannot be less than 5. So we've put in a divisor 2 here, right? So it's supposed to fail. And this is the part where we mentioned that when you run this, the validity will be false. So this is a failure test case handled properly. So it says that this is the error. There is a wrong condition in line 22, which is, I'm assuming, somewhere, but yeah, the divisor has to be greater than 5. That's the idea, right? Yeah, so that's that. Then we verify that the value is 50, which is 50 because it's not been divided. Then we divide again by 10. So now it should divide. So you see, we divide, the divisor is 10, and you divide, your divisor is 10. So 50 by 10 is 5. So you verify again that the stored value is 5, and it is 5, so it works. Now what you try to do is, so why did we take the owner? See, this contract is pretty stupid and pretty useless, but the point that I'm trying to get across is what all you can do, right? This contract is, you're never going to do mathematical calculations on smart contracts on blockchain. That's never the point. The point is to make you understand what is possible, what is not possible. Uh, so here there is a function called make zero. What it does is it verify equal. It verifies that the data.owner that is stored in the contract that was initialized here, this owner, is the sender. So sp.sender is the person who's sending the transaction, right? So as we discussed, in a blockchain, different people can send transactions, right? Everybody who has a private key can send a transaction. So what you're verifying here is only the owner is sending the transaction, and therefore only the owner can make the value 0. Of course, you can replace the value by 0, anybody can call it. So don't go by the logic. What I'm trying to show you is there are some functions that can only be called by an owner of the contract, or no, this is a permission control within the contract, right? Um, so yeah, this is, so we tried calling the contract. So we say run sender is Bob. And when Bob is sending, this should fail, right? So Bob called it and it failed, saying that only owner can call. Brilliant. And then Alice tried calling it to set the contract to 0, and it, yeah, and it became 0. And towards the end, we verified that the stored value is 0. So this is what is known as formal verification. What you did is you performed a series of steps to sort of understand that your contract is behaving correctly, right? Now, I quickly want to show you the difference between the smart pi contract and what is known as the Mickelson contract. If you look at, so boys and girls, this is the Mickelson contract, and this is crazy. This is like, if you have to write this, this is going to, so you see, these are all operations. If you've done assembly language, you would know that these are all assembly level opcodes: pack, swap, dupe, duplicate, all of these things: compare, equal, if. So I mean, this is readable to some extent, but it's very hard to write this, right? So that is why, and this is what is deployed on the chain. On the chain, what exists is this assembly level Mickelson language, which we touched upon. It's a low level. um, I think we touched it somewhere. That's it. Anyhow, I hope you remember. that the language, yes, the language that it used is Mickelson. It's a low-level stack-based programming language. So this is essentially the, my bad, sorry. This is the language, and it has a stack, right? And yeah, so this is the storage. So yeah, basically what I'm trying to tell you is it's much easier to write this, much more readable than this. So always write in, smart pipe. And yeah, this is what is deployed on the chain. So it's sort of very hard for you to understand what this is. But anyhow, what we're going to next and last do is we're going to deploy this contract on the actual testnet, right? So when you click here, it's going to deploy the smart contract. Actually, like it's going to actually deploy the contract on the testnet. We're going to deploy it on testnet and not on the mainnet because mainnet costs money and I don't have money. So we're going to deploy it on testnet where we can use test money, right? So first we switch our network to Edo. And yeah, so there are a couple of options. I use the Temple wallet here. So this is a Temple wallet, which is a browser extension. So I'm going to unlock it. Hope you all can see this, right? So this is a wallet that you can install. It's you can. It was earlier called as what was the name? Um, it had an interesting name, but it's now called Temple. Don't worry about this. So you can search for Temple wallet. It was called Thanos, of course. So yeah, you can use this. I have some test balance here. It's very simple to create an account here. It gives you an account, and the way to receive Tezos is using a bot. Um, uh, and I'm probably not gonna show you that, but or should I? Just give me a second. I hope all of you are on Telegram. If not, uh, you can get in touch with I think Sneha. She's your or with any of the organizers. They can help you connect with us on Telegram, and we can give you sort of free testing tokens for you to sort of test this. But anyhow, so yeah, this is how you use the wallet. So we're going to use uh, Temple wallet. Yeah. Um, I'm not sure why this is not working, man. Is it because? Let's see one second. It is possible that something is broken here. Let's see. Okay, possibly an issue. Let's try. Interesting. So it is not recognizing that I have Thanos installed, which I have, which is the Temple wallet. Let me refresh it and see if that helps. Yeah, as I said, this is a product that is in development, so there are issues with this time and again, but it does mostly work. I've used it quite a bit, so hopefully it'll work. Uh, okay, let's try. Let's try some other net then. Probably that would solve. Or let's try Delphi. I think Delphi could work. All right, so I'm just going to use. I think I'm just going to use uh, my wallet that I have in SmartPy. Um, Okay, this is just sad. Let me quickly get my key. Just give me a second. So I have another key that I can sort of inject here, but generally the temple works, so you wouldn't have to face this issue. So too bad. All right. Am I still presenting? Can you still see my screen?
Yes, sir,
Or
we can
not?
see you.
You can, is it?
Yes, yes, we can.
Awesome. Sorry for all of this, but yeah, it does break at times. So let's see if this works now. So this is my key that I generated long ago, and hopefully it's gonna work. So yeah, there it is. So account loaded with success. This is something that I generated long ago, which is coming to use now. So it has a mnemonic, which is basically these words that sort of let you remember your or memorize your contract easily. This is the secret of the account. This is the amount that exists in the contract, I guess. This is the public key. It always begins with the TZ1. Okay. And there's some passwords and some other things. I'm going to save this to faucet. And this doesn't have any balance. All right. So, okay, this doesn't have any balance. Let me see if I have another account that I can show you. I should have another account which has some balance, I guess. Or just let's wait for it to get activated. I think then you would have some balance, hopefully. In the meantime, I can take some questions. This is taking a bit of time. All right, I'm going to stop presenting. So Asta has another question. So there can be no initial amount I can have in my wallet if I haven't had any payments yet. So Asta, to create new accounts in Tezos, what you would need is you would need to fund them with a little bit of amount to sort of create to bring them to life. This is not the case with Ethereum. You can create free accounts, and which is why we're going to face some difficulty here. So yeah, the account has been activated. We'll reveal this account, and then we'll feed in some balance, and then it becomes activated. Yeah. Uh, so yeah. So the question, coming back to the question, there can be no initial amount. So yeah, even if you create an account, it is always going to have some balance, right? Yeah, but yeah, basically the way to create an account is sort of pay to the account. So yeah, you're going to always have balance in the account. All right, so let's try to get some balance from the faucet. This is another way to get, balance apart from that Telegram bot that I was talking of. All right, any other questions that we have? Okay, I don't see anything. Let me quickly share my screen again, and I'll show you where I was and where I. All right, slightly conscious of the time as we are slightly late because of this. So yeah, this is the testnet. So we're going to try to get testnet funds and see if this works. All right, I've copied this. I think this is the account that has balance now. So let's see if this works. Nah, didn't work. All right, I'm kind of guessing that this is not going to work unless it's going to check if this works. So basically, as I said, okay, Tezos is a blockchain which is self-amending, right? So it keeps sort of changing, and there are new networks that come in time and again. So what Delphi is basically is a old network, right? And Florence is a new one. So that is why these. Sorry, there are people at my office that are waiting for me. Yeah, finally. So this has 300 Tezos balance, and we're going to use this. And hopefully, this is going to help me deploy the contract and show you guys, give you a feel of it at least. But yeah, this is not supposed to be this hard generally. Because okay, in the meantime, I would probably just quickly discuss a few, ideas you can note down for, I'd say, like, for building in the hackathon. So something that you can build up is, I suppose, a micro lending platform, right? So you can sort of do small miniature loans, right? And they can be, that there can be an interest associated with that. So that's one idea. You can build marketplaces around the blockchain. So marketplaces for NFTs for different things. Let me see. I have a couple of things in that I written down somewhere. But anyhow, so this looks that it is done, and I think we should be able to test with it. So there we have 300 Tezos in this account. I'm going to try to deploy the contract and see if it works, right? So this is how we deploy a contract. This is the hash of the contract. This is the parameters of the contract. This is the contract actually. I'm just going to accept and let it go. Okay, so there is an error which we're going to probably fix from this place. So I have my address copied. I'm going to just paste it here where we deploy the contract. So it's going to be this now. Yeah. Or actually, it's going to be this. So here I'm going to have. Yeah. I'm going to run it now. And again, try deploying it and hope it works this time. So the ideas that I was talking about. So you can build an audio streaming platform, right? For artists to sort of monetize their artwork and create NFTs that can be bought, sold, that can be tokenized. You can build a platform to mint tokens based on demand, which are known as fungible or non-fungible assets, right? So that is something that you can look at. And another thing you can do is build a micro lending platform, as I said. So micro loans are small loans, and you can build a real estate marketplace where you can buy, sell real estate. So that is another thing you can do, right? All right. So what I'm going to do is I'm going to quickly remove this owner. I'm conscious of time. We're not trying to waste of time, and I'm going to hope that this works. Let's see. There is no make seat. I'm going to try deploying this. Hope this works. Damn it. Line 38. Oh yeah, of course. So yeah, let's try to deploy this contract. I'm more than confident that this will pass through, and then I'll give you. I think Vidit has a question about MERN stack. So the tools that Vidit you would use are basically, as I mentioned, you would use Conceal.js, Taquito. You would use Beacon SDK, which you can see here as well. Damn it. Okay. Did I not switch? Oh, yeah, my bad. So Delphi, we're going to use. Yeah. All right. Trying to deploy the contract again. Hopefully it works this time. All right. So there is an issue. I'm not sure what that is, but I'm not going to waste more time on this. I'm going to give you a small script, and a small demo and a recorded form, hopefully that you can use to deploy this. But yeah, there is some issue with the network because of which it is not passing through. Accept my apologies for this. And yeah, I'll stop my screen share and open up for final questions. And really sorry, we couldn't show you the contract in action.